Anytime we're dealing with percentages, I'm going to use the open formula to keep track of everything. Now, this is a specific case that has percent increase and decrease, so that's going to mean we're going to need the modified open formula where we reflect the increases and decreases with a 1 plus or minus. And on top of that, we have two percentages here. So what does that mean? Well, luckily with percentages, since it's multiplication, we can just add in all the percentages at once. There are ways to do this in steps, but we don't need to do them that way because we can kind of do multiplication in any order we want, so we're just going to kind of do it all at once. Let me show you what that means. The unknown in this case is the O. What is the original price? So I'm going to make that my X, so let's just put that down. Now the first piece here is that we are offering a 15% discount. So discount means we are minusing, right? That's a smaller price. So we're going to use 1 minus 0.15 to represent the discount, right? It's 15%, but it's 15% off. So that's a decrease, and that's what the 1 minus P here is going to do. It's going to represent that for us so that we can keep the percentage in the right way. Then we have a tax, right? A 10% tax. Now, a tax is adding money on, right? So that means we have 1 now plus 0.10 because that's 10% as a decimal. And that equals a new final cost, a new value of $14.96. Now let's start to clean this up a little bit. So X is going to be 1 minus 0.15 is 0.85, and this would be 1.1. And that's equal to 14.96. So I'm going to take my 14.96, and this is what makes this open formula so useful, is when we actually do it, we are going to divide by these two numbers, not multiply. And that's what we associate with percentages. We associate multiplication, but the SAT tends to ask them in ways that involve dividing instead. So I'm going to do it in two stages. 1496, I'm first going to divide it by 0.85, okay? Then I get a number, and I'm going to divide that by 1.1. So notice I'm not going to enter it as like a multiplication step in there because you would need extra parentheses to do that. And right now I'm working with a very, very basic calculator. So I get that X is equal to 16, and that is the answer. Now, we could have also guessed and checked here. It was absolutely possible to just start with these kind of numbers and do the percentages and add them in, and instead of doing this kind of work backwards thing. But I wanted to show this open formula way because there will be cases where that's not possible, and the SAT is very consistent in this kind of trap. So we really need to be careful. If we had done this in some kind of weird way, not really representing the formula correctly, we would definitely get choices like B or C. Those are very close to 16. But it matters, and so trying to reverse a percentage is difficult. The open formula lets us do it in a way that is organized and consistently correct.